Okay, and a very warm welcome from London and many other places to our latest Talking Industry event. My name is Andy Pye. I'm consultant editor at DFA Media, who publish a range of print and online titles in the engineering and automation fields. Today, we're going to talk about smart maintenance. I'll come on to that in a moment. And we have two excellent speakers, and sneakily, we always talk to our speakers beforehand to discuss what we're going to talk about. And on this occasion, they've also sneakily been talking to each other. So we'll be talking about how their relative technologies can integrate together, which I think will be a really good aspect to cover. Smart maintenance, it's not just about the tools, it's about the culture and the mindset shifts that organizations need to take in order to reach the utopia, the sunlit uplands of measurable cost savings, improving productivity, making smarter decisions. So that's what we're going to cope with. One of our speakers, Donal, who's from PEMAC, he's escaped the gale force winds of the weekend by living in the UAE. I'm sure they get other issues there. And today we've got a glorious, still day with blue sky. And it occurred to me that's quite a decent analogy with maintenance as well. You know, you could have a really well organized, no panic, perfectly still form of maintenance where everything is prepared, measured, and achieved. Or you could have the gale force wind version where everything's blowing around uncontrollably, trees are falling over, and it's how to get to that kind of smooth, digitally motivated environment that it really is what we're aiming to do. So let me just, for the benefit of our attendees, just tell you how we work. Our panel discussions are firstly unscripted, and secondly, we want to get as many involvement as we can with our attendees. So if you have a question, you can put it in the chat and we'll take it at whatever time we think it's appropriate to deal with it. So questions, comments, very welcome right from the start. We will have a Q&A at the end, but you know, we have a Q&A all the way through. So the more, we may even invite you to join us in video and talk to us as well, which might be a bit daunting, but if you'd like to do that, let me know in the chat and I'll see if I can arrange that as well. So it's a conversation, and hopefully everyone will get something out of it to take away and develop their maintenance programs. So let me introduce our speakers in reverse order. The first is Peter Keckes, who is Strategic Account Manager UK and Ireland from Red Lion Controls. You'll hear from him second, and he'll talk about all the devices that collect data from machines, how it works, whether you can work with new machines, old machines, but the whole issue is gathering data and then delivering it to somewhere where it can be put to good use. Interestingly, Red Lion Controls were acquired by HMS Networks about a year ago, actually. So I might quiz him a little bit on that in due course and how that's going as well. He didn't know I was going to do that until just now, so that's something he can prepare for. But he'll be our second speaker because our first speaker is Donal Bourke, and he's from PEMAC, which is an Irish-based company, and they are providers of CMMS systems, which is computerized maintenance management systems, and all the software and services that go with that. So, in other words, Peter's data can be fed into Donal's software to get the best smart maintenance program. Donal's going to kick off by giving us a general overview of what smart maintenance is about, and he's very cleverly put together a slide where he's found a definition for each of the words in the word smart, S-M-A-R-T. So I'm going to pass over to Donal. He can explain that in more detail and put his slide up on the screen. Over to you, Donal.
Great, thanks, Andy. Let me just share the slide. Hopefully you can hear and see me okay still, yeah? And
Yep,
you can
all
see
good.
you can see the slide. Yeah, no, thanks for the opportunity to speak today, Andy. Really appreciate it. And everyone at Talking Industry, and for the attendees for attending. When you mentioned the topic to me, I wanted to try and create an analogy around what smart maintenance is. So I suppose really for PEMAC, it isn't just about adopting the latest technology. So it's about how organizations can transform by aligning strategy, people, and technology. Because the technology is only as good as the people and the organizational strategy to help realize the long-term value, you know. So what the slide actually illustrates is that it's a complete approach that brings together strategy, maturity, adoption, reliability, and transformation. And how I visualize that is that it breaks it down into each gear as a vital part or a piece associated with smart maintenance. So maintenance is really effective when you have, firstly, the S, which represents strategy and support. So aligning your maintenance goals to the business objectives, and then having the support of leadership to help drive that change with the technology, making the organizational and cultural changes that some technologies will implement as part of their adoption. The M represents maturity and measurement, and that emphasizes that you can't improve what you don't measure. So a key aspect of our business is that we help clients assess a level of maturity, where there's opportunities to improve, where there's potential gaps, and ultimately you're identifying quick wins in that. So if you can measure, assess your current maturity, assess gaps, then that can help you identify potential technologies that can be adopted to help improve your organizational processes, your maintenance as you go forward. A represents adoption and adaptability, and what that emphasizes that is, although the technology is great in itself, it's only as effective as the people that use it or adopt it, and their adaptability to using technology in that. So the more the organization embraces the technology and the users embrace the technology, that's really the key to unlocking that real-time value, long-term value for the organization. The R represents reliability and resilience. And what we mean here is that although through the adoption of the technologies, organizations can move from typically more reactive-based maintenance to proactive maintenance, which can cut costs. Technology also has the ability to build a more resilient organization. Yeah. So they can build systems that can withstand more unexpected issues in that. And then finally, transformation and training are key to maintenance success. So organizations always have to stay ahead. So it requires continuous improvement, continuous development. And as a result, organizations continuously have to learn on how to adopt and adapt these technologies to their organization and to the strategies. So when you combine all of those elements of that smart maintenance, then what you see on the right-hand side of the slide are potential savings. And these are based on what I would say industry-based assessments, results, studies that are there. They're readily, you can find them readily on the internet. We've taken a sort of a conservative view on it, but the results can be impressive. You can see 30+% cost savings in maintenance, 15+% in extended asset life cycles, and even organizations moving fully paperless, which a lot of our clients have done over the last number of years as well. So that really depends. The level of savings and cost savings or that organizations can achieve depends on the level of maturity and their willingness to adapt culturally and embrace the technology and adopt it, really. So I thought that might be a good sort of representation to tie in the discussion what we're going to discuss today around smart maintenance, automation, and more proactive approaches to maintenance culture within organizations.
Thank you very much, Donal. That's really good. And Peter, feel free to come in as well as I ask some initial questions. The first one would be flexibility. Would you include that in your A rather than an F, which isn't there? I mean, adaptability, flexibility, are they the same thing? And how would that be affected by the sorts of company sizes and the sectors that you would be working with?
Yeah, flexibility. Yes, yeah, I would agree with Jenny. It probably is different, slightly different to adaptability as well, because adaptability here, when I'm talking about it, adoption and adaptability, I'm talking at a specific organization level or industry level, but potentially flexibility. There may be more rigors on certain industries in comparison to others that prohibit certain levels of flexibility. So like if you work in oil and gas, for instance, safety is a paramount priority, whether you're in upstream, downstream oil and gas and that. So what levels of flexibility do you have to adopt certain technologies within your facilities and plants, and based on regulations that might be imposed upon you? And then yeah, that might constrain the types of technologies, but it's still, I think that's probably where I would see the potential difference between flexibility and adaptability. You know, different industries, different requirements, regulations can impact and could impact flexibility.
And you gave on the right-hand side of your slide some of the savings. Where in those measures would just proactive maintenance figure? You know, because how do you measure it? The benefits of you know, not having to keep a lot of spares and being able to predict when components are going to fail. Where in that sort of right-hand list of benefits does that figure?
Yeah, so it like just related to spares or in terms of overall
Well,
maintenance?
yeah, overall, yeah.
Yeah, I suppose, like, I mean, it's key for any organization, as I said from the outset, before you adopt technology to understand the value that it has delivered for you, you have to measure where you are today. So um, measuring your current um, um, spare parts usage, your expenditure on spare parts, as an example, as you discussed there, then adapting and or adopting technology to manage that as integrated maintenance, whether it's through a CMMS, having spare parts and inventory managed there alongside your planned and unplanned maintenance, and looking at the statistics and analysis of that over time and optimizing that based on the data that you're receiving back. You can very tangibly see what the results are if you put in the measurement metrics before and after, because like with CMMS software, you have those KPIs, you have the measurements there. So the history, as long as you're recording that, you will have the performance improvements readily available in the KPIs and reports that come out of these systems.
If you don't mind, I will add some things to it, because it's really a matter of the industry. What is the value in the industry? If you consider manufacturing, for example, in pharmaceutical industry, your probably biggest loss is not how often and frequently you can take a spare part on a place. But if you do have a breakdown through the middle of the production of the batch, you're losing whole batch, and then you're counting the loss of production, loss of the market value, which could be counted for one batch around 100,000, even more. Then the spare parts of replacing, for example, pump, which costs 500 or 1,000 euros, it's not that big deal compared of the loss of production. If you're talking about infrastructure, the value is completely else as well. And for example, typical water utilities in UK, they are massively fine if they do any pollution. If they spill some water, might have a spill of sewage. If they don't know that upfront and they don't know when some pumps or engine or something's in the cleaning system it's about to fail, and they will have a spillage. Again, the value is loss of name, but also loss of revenue, because they will need to put the money which they earn, the revenue, into the paying of fees and fines. And for each company, each industry is actually the value somewhere else. Yes, maintenance, if it's predictive or standard and preventative, there could be cost which could be cut by some smart management. But to be able to see where the biggest value is for loss of the revenue or loss of the business or loss of the renomme and name, I think there's another things to consider in this big scheme.
Yeah, that's a really good point, because some of these benefits are almost intangible until they've happened, I guess. And that depends how aware the senior management are in terms of setting a strategy to prevent such risks from happening. So it's a risk management issue in many ways, isn't it? And that comes back to the cultural point that that we started with. So how do we get the culture right in order to get the maximum benefit out of smart maintenance right at the beginning? And that, I suppose that's what I was getting at when I was talking about company sizes, because small companies can often move with fewer constraints than large ones, possibly.
It's certainly true. Yeah, smaller companies are more flexible in terms of they're probably less bureaucratic in terms of structures, processes, governance, and things like that. They can react quicker in that, but it doesn't necessarily mean that they do. Because some of the larger organizations will be more strategic, and it becomes board level KPIs. So the smaller organizations may not have the same level KPIs, whether it's sustainability, whether it's risk management, whatever. It's maybe just product production, uptime, etc. And that. Whereas the larger organizations will have a lot more board level KPIs that filter down through each of the functions and that, and then the culture of change is driven from the top to achieve those. Yeah, and it permeates. Certainly, we see it across a lot of the industries, regulated industries that we operate within, in terms of life sciences, oil and gas, and that as well. That does permeate down into each function of the business, and as a result, those KPIs are passed on. Yeah. So culturally, I think might be a little bit slower from a larger organization perspective, but the willingness to drive the change is typically there, as long as you can align it to the business objectives and goals. So if it's a sustainability goal, if it's a safety goal, a lot of organizations, the majority of organizations, larger ones, will have sustainability, they'll have safety, and they can all be linked back to maintenance. Whether, if you're optimally managing and planning your maintenance against, say, original equipment manufacturers' design criteria for their assets and that, then those assets are performing at their optimum. And as a result, there is a correlation between energy efficiency, usage efficiency, etc., and spare parts efficiency. There's also, by doing that, there is a relationship to safety as well, proactively maintaining these equipment. So culturally, if you get it right, you can communicate that better to a board level, how adopting technologies such as CMMS or other maintenance technologies can help achieve the business goals and objectives, and how it relates, and then that culture can permeate down within it. As you said, smaller organizations are a little bit flexible, so a little bit more flexible. They can do it quicker potentially. You know, if the willingness is there at board level, they can react quicker. Yeah.
Yeah, so you've given a good shout out to the larger companies in terms of their ability to manage regulation and therefore get things right from that point of view. Whereas perhaps smaller companies, a lot of the executives are trying to do several jobs at once in an SME, for example, which might be a disadvantage. So I suppose there are issues either way, and I guess it also depends what market sector you're working in and how safety critical, how critical your ability to have traceable business is important. Perhaps it's important everywhere, but it has to be done in obviously pharmaceuticals, as Peter mentioned, and food and so on. Peter, what's your kind of experience of the different types of company that you're working with? And then we'll come into your session about what you do, which is principally in the measurement area, isn't it?
Yeah, considering, I spent over the decade working actually in the software industry, and I know exactly where Donald's coming from. My expertise was a bit more general because working in IoT, at times when I started, it was the new marketing term coming out, but actually it was not that extremely new. IoT, it was for me, I used to call it a SCADA on steroids, where you're starting to stop only monitoring what's happening in the real life with the your real assets, but starting to interface that with different IT systems, but mostly interface it with the people. And this is the cultural things which Donal was mentioning. People on the beginning, they didn't know what to think about it because, everyone's coming with this kind of polished software solutions. We do see a value in it, but how we're gonna roll that value into mind of the users? And that's always, I think, one of the biggest hurdles. But that's one of the hurdles, I would say, and that's why actually coming with the Red Lion after a decade working mostly in the software industry, I said to myself, it would be good to understand both sides. And because of my background well behind it, which was an OT application engineer, I used to work with the hardware quite a lot and have seen their needs for it, but also have seen the variability for it. And then I would say, I would put it this way. I will put one slide which actually kind of symbolize that how we seen it. Hopefully it's up there and on. In my experience, I know the companies invest a lot in a software, and I'm not talking only about software which helping them manage their productions or the maintenance or what literally any software, because the companies are run by the software, which is a bit more simple in IT side, where your software is a CRM system, ERP system, or human resources system, or your Office and 365 these days, but Word, Excel. But the point is coming when actually we're talking about software which sitting on the top of your operations. And the operations are usually fit with multiple machines, sensors, PLCs, controllers, and it's not like in IT when they're talking same language and can interface easily. It's complete opposite. They are all different. Depends of the age, depends of the system, depends of the manufacturer. Actually, you won't find two companies or two factories same unless you are in a very strict, clean environment. And my experience, for example, with companies, the chip manufacturers, they cloning their companies. Then if they do have their factories, then they have a factory, for example, in US, and they want to produce same type of chip, they will clone factory in UK or Asia, and they will be completely clones. But if you're talking about pharmaceutical or food and or if you're talking about utilities, there is no one factory which is mirroring the other ones. And many times by the acquisitions, these big corporates, they actually acquiring not only new production which producing, for example, cakes or breads or food, but they actually acquiring completely different technology from probably different manufacturer, which running that factory. And that's where we coming from. We trying to interface all these hundreds and hundreds of separate data, which looks like pile of hay, and put the order into them in OT layer, in operation layer. And why we're doing that in operation layer is pretty simple. I spend working in IT in software level with this OT data, and I can tell you, one machine doesn't have a same register, same name, and this not to have a same name is very hard to interface into system, for example, like CMS, and have a really good visibility of what's happening, because they not even talking same name, same language. And that is something which in industry is probably known as unified namespace. This unified namespace could be some part of the real data, your real view of your factory in real time, but also historical one. You need to get this data in some way there. That's where Red Lion, starting 50 years ago, probably focusing that times on the sensors, on panel meters, over the year developed technology which is capable to talk. I think we do have over 300 protocols talking to different machines. Doesn't matter if it's Siemens or Alan Bradley or Schneider, whatever you can think of there, we can communicate with it. Or we can communicate directly with physical sensors. The sensors could be analog, digital, doesn't really matter for us. Then when we acquire these data, what to do with them before you sending them into OT layer, I think it's a very great idea to create your unified namespacing, because in that case, you structuring the data and on the OT layer by people from OT, which understand the OT data, by simple drag and dropping, putting them into structure, which is very easily then readable or push forwards towards the IT layer. And the IT layer, it could be SCADA or it could be MES, it could be ERP. But in many cases, as we're talking today about maintenance, it could be the CMMS system, which actually with real-time data and real values from the machines, it's much easier to work out on predictions, what with the machines gonna happen, where the machine's having a problem, or you do have an infrastructure where it's not coming only the alarm to you when something is broken, because that could be quite late. You have to think about it. What if this gonna break? And that, you know, it doesn't need to break straight away. It doesn't need to break within weeks. But in that case, if you know when something is not right as it should be, you can start to plan. You can start to plan your maintenance, your spares, your replacement, your engineering resources to do replacement of the machinery when it suits you, your manufacturing process, your processes within the company. In that case, the cost of it is much smaller because it's all well prepared. There is no loss on the manufacturing capabilities, and there is not a loss on the revenue or renomme. That's where Red Lion's coming with different technologies of accessing the data. But of course, we also talking about security. You want to access them securely. You don't want to have a interference between corporate network, OT network, internet, and cloud applications. This is in our heart. It was part of our acquisitions over the decades back when we started to look into secure network management, and that's become part of the data acquisitions, because it's not only necessary to acquire them, but it's acquire them a secure way and making sure there is no interference from other layers. That would be probably around it what I would like to talk today. And Andy, you are completely right. A combination of the software, which Donal was talking about, and the hardware, which is on the OT layer, it's important. That's giving the right real picture. What is process of change for factories they need to go through? Because it's not easy to just say, yeah, we're gonna do it. Many times I met in a different proof of concept to do it for the sake of technology. In that case, it's completely failure. You need to set up and change the culture of the people, understanding the technology is not there to fight them, take their jobs, but it's to help them and work with them to make that process and factory better.
So there's two things there. I mean, let's first of all talk about this importance of security. What are the risks of data being insecure, and where are those risks most likely to appear?
Right. If you're looking into utilities, everyone knows how utilities are structurally necessary for our society to work. And if you're gonna look into clean water, you don't want anybody to change a formula where the water is processed and cleaned and chemically processed to be drinkable for us, because that could ended up with poisoning millions of people. Then from that point, the security is absolutely highest priority in this kind of operation. Of course, there are other options, other possibilities. And if you're looking, for example, pharmaceutical industry, there is lots of know-how how to produce something. And that's another thing which people doesn't like to just give it go. You know, we work on the processes for many, many years, for maybe decades. Lots of resources was put into that to produce something. That's another reason why the security is important. And security, but also we're talking secure accessibility of the data. It maybe started with the COVID to have a much bigger like view when secure access to the data or to the plant or to the factory is important. But I spent well before that, and I'm talking now 15, 20 years ago, on securely accessing remote power plants, hydro stations, wind turbines, or separate generators, because that's my background was in power engineering. And, you know, there was not like ever mentioned when this is necessary, but it was, because the remote sites were inaccessible, and many times before you go there and fix problem, you needed to know what actually the problem is. One of the first project, but I spent even before that in a machine analysis, which I needed to analyze upfront what could be wrong with the machine. And the machine was worth probably $500,000, but what is important to there, because each part costs a lot and needs to be validated. It was in a very restrictive environment. You needed to travel there, find out what is wrong, go away, let the factory or the spare parts to be produced and validated, and then travel again back. This cost company a lot of money, lots of value, but also it took very bad feeling from the customer because his machine was not working for weeks, for months. How to speed up this process? And that's where the remote access coming. Of course, remote access people are many times afraid because, yeah, it's through the internet and could be hacked. And yes, but it's important to understand there are secure way and there are secure technologies which will enable you to do this into highest level of security. And these projects are out there live for many years, not current. I'm talking about decades working.
Donal, you have your hand up, so you obviously want to intervene at this point. So what's your take on the security side?
Yeah. Look, similar to Peter, I worked So I worked in for a global automation company for about 14 years, multinational automation company. Worked in providing production control systems, distributed control systems, SCADA systems, and that. Having got to know Peter and Redline recently as well, it is interesting. So the technology that is there is independent of your PCS or your DCS or your SCADA system. So it's an independent backbone data acquisition system, gathering data, but not doing control. So that having that as an independent system that is not directly to connected to control elements on that physical plant, then allows the capture of data and analysis, which then can be used for maintenance, right? The types of systems that Peter has there essentially can help someone like PEMAC in terms of optimize maintenance strategies or improve asset reliability, because they're an independent system that's doing condition-based monitoring. So they're looking at whether it's temperatures, pressures, whatever, through their secure data acquisition systems, and then transferring that data securely for further analysis or action. Yeah. That data then can be analyzed and acted upon. So whether that's, patterns, looking at patterns on particular pieces of equipment, which then could be said, okay, that we're looking at runtime on that, or we're looking at particular temperatures or whatever else, we can then create an action on that. Okay, if that sensor reaches this temperature 3 times in an hour, this requires an intervention. And then we create an automated workflow within maintenance, or we create an inspection, whatever. So having that secure access to data that's independent of your production control system, your DCS, your SCADA system, is a very effective way to do condition-based monitoring, provide data securely out, but without impacting your day-to-day operations in terms of whether you're producing a batch, whether you're, as Peter said, keeping the water flowing, clean water supplies flowing, or whatever else. These independent technologies that are acquiring data are very useful to provide additional layer of data analysis insights that doesn't impact your day-to-day operations, but then can feed into systems like ours and that as well. Yeah.
It would take presumably quite a lot of time often to interpret the data in terms of what does it mean, and what do certain temperature aberrations mean, and there's presumably a learning curve.
So there is what I would say on that is, right, so typically your operations and maintenance teams, particularly in organizations, have are very knowledgeable of the assets that they're managing and maintaining on a day-to-day basis, right? So you can translate some of that knowledge and insight. So very often we would hear clients say, okay, well, we know this machine, and if this happens so many times within a particular time frame, we need to change a filter, we need an inspection, we need this done. And you can create those simple rule-based scenarios and actions that automate workflows and create efficiencies within the software, just based simply on the historical knowledge of the operations and maintenance teams. Or, as we're talking about today, in the predictive space, it's about taking systems like Peter's, taking IoT sensors, maybe linking them into the data acquisition systems like Peter's, ensuring that the data that you're capturing is correct and representative of the analysis that you want to do. So defining your use case. What is your use case for this data collection? Is it predictive maintenance? Is it something else? Or do you want to determine quality? Or we are talking about maintenance here. So the teams that are within that organization, if they define the use case well, they define the data points well in terms of the measurements. Is it temperature? Is it pressure? What else? What other aspects do we have to get data from over here as well? Because there's correlations between these. If you define that well enough, then the sample of data doesn't necessarily need to be long if you define that up front and you have good representation within a month, 3 months, whatever it is. it really, really depends on the use case, the data points, and that as to how long it will take, you know.
Absolutely,
How do you,
sorry, Andy.
go ahead.
Yeah, absolutely. This is very, very crucial and important information. Many times I run into companies and they saying, "Oh, we do have a terabytes of data." And I said, "Yeah, what kind of data you have?" And they saying, "Oh, we need to acquire this data." And as you mentioned, there are temperatures and there are pressures. And I said, "How that relates to machine?" So, oh no, there is no relation to machine. That's our environmental monitoring system, which collect these data because we need to collect this data. I said, okay, but do you have any relation data to the machine if they affecting the machine? No, and this is where they need to really think about data from years and years being acquired and stored. But do they have actually value for the companies? You need to know what data are important. If your machine is breaking, what's the machine is doing? What is the fault? What data are affecting that actually machines? This is a data what you need to collect. I had a use case for maintenance, and they wanted to understand and how the machines breaks. And they send me, I don't know, gigabyte of data, and there was no one failure. And I said, you can't do that. You can't do any analytics or the predictive maintenance on a machine which does not have a faulty point in historically acquired data. Oh, then take it an alarm. And I said, alarm is fantastic things because alarm is set up for somebody to be alerted something is wrong. But what happens when you do have an alarm? The engineers will come and try to fix that before the machine breaks. Again, you don't have a breaking point. You will have 100% accuracy on alarms because the alarms could be easily seen and predicted when they're happening, how is rising temperature to the alarm point. But as Donald was mentioning, these correlations of the data can be or they are actually very important at the beginning to set it up before the projects will even start. But then there is necessary a patience of people to understand if you're running CMMS system, if you're running some analytics, if you're running some, these days they call it AI, on top of that, it will need a time to learn and see that if it's going something's wrong there, we will be able to predict it. If there is nothing's going wrong, that doesn't mean system not gonna give you help. It will. A massive help, simple anomalies, which could be set up by the experienced person from the shop floor saying, oh, if I see this anomaly, temperature jumping up and down for X period of time, this is likely a fault. You can train and set it up in CMS system, this informations, and give them an alert. And that is already massive help for them to understand. I don't need to watch the temperature meter there and sit there 24/7 because production is 24/7. I have a clever system to notice this problem, notice this system issue, and let me know when it's necessary. Then I can utilize my time to do something more important. For example, developing better processes within the company.
How do you actually merge basically opinions from shop floor workers who can assess what they've got in terms of experience and how that relates to a potential failure with data coming from sensors and similar systems?
It's not easy. I mentioned before, it's usually the operation people, the maintenance engineer, the people which actually using the machines to operate, which know and do have a knowledge of these informations. And unfortunately, it's usually IT people which integrating new systems in the shop floor and telling them how to do things. And I always seen these OT and IT separations and no communications between these two segments of the factory departments in any corporations or in any organizations. And that's something which it must be changed. It must be changed because other way they will all talk different languages and never speak together.
Mm.
And I always saying, and this is maybe a bit harsh on IT. And believe me, I used to work in IT quite a lot. But simple, if you put a fault in your email client and you not receive email, for example, for a minute or two because your server is down, what's gonna happen? Nothing. You won't even notice because you're sitting there and your email pops out. Ah, yeah, I received it. You not even notice when there is 2 or 5 minutes delay. But if your factory will stop operating for 5 minutes and you will have a fault. And now imagine is you do have a material which is going through the furnace to dry out, and the furnace does have a 900 degrees, and we stop moving. Then if we stop moving, that means it's gonna melt. Very likely it's gonna melt and pollute all the machine. You will need to shut the machine down, and will take you probably weeks and weeks to clean it up and put the production back on. What you ending up with machine which went 24/7 production, now suddenly not producing for weeks, and you have a massive loss of value there. Then I think when somebody from IT telling you, and you are in operations, how to do things, I said, no, sorry, I can't do it this way, because unless you're gonna take a responsibility of implementing your IT system in OT operations, and opposite, if OT person would not understand the IT problematics and cybersecurity and will have no clue, he will not care to. And I have seen and enjoyed that myself, where I scared a little bit of a client because he said, oh, just connect to this Ethernet switch and we'll see if we can get some data. And we get all the data. But I told him anybody can stick his laptop into his port and suddenly have access to all the data. I'm not going to say what technology was, but it was extremely critical and safety guarded factory where I suddenly have access to all the operation data. And they were cheering because they suddenly get access to all the data. They were very happy. And I told them, but there is a massive security problem because I should not be even allowed to be accepted in network with my laptop because it was not configured to work with your operations. We're supposed to be secure. And this is what IT and OT people needs to realize. They need to start to work together and understand each other issues. And that times we can have a successful projects which will run smoothly.
Donal, you want to come in there?
Yeah, just on your point there, Andy. So going back to let's just look at whether it's production, operations, maintenance, staff. You cannot ignore the experience and the knowledge that they bring, and 100% rely on just the technology to make the decision for you. Yeah, they are critical in the loop, part of the process. Technology is not going to replace the people who understand the operating envelope of the assets or the plant and the production processes. And I think it's very important to, when we talked about that adoption and adaptability, it's very important that they're involved in every stage of the process. Like if you look at predictive maintenance and you look at data analysis, etc., and that, they are the inputs into that loop who will provide the optimization of those models and data to refine them further. Was that right? Was the assumptions right? Did the output reflect what we expected it to reflect? No. And that because if you look at any production facility, whether it's a pharmaceutical plant with a batch reactor, if you look at a downstream refinery in terms of its distillation columns or other parts of its manufacturing processes, typically the production, the operation staff, the engineers that are there know the operating envelopes of these pieces of equipment. The original equipment manufacturers who designed those pieces of equipment will give handover documents with operating parameters and maintenance, suggested maintenance intervals, and strategies how to maintain these pieces of equipment. As the engineers are operating and maintaining these, they understand what is the extent of the operational envelope and what maintenance intervals and interventions work well. Does that mean that they can't be optimized, that they can't be improved? No, it doesn't. And of course, you can, with technology, extend those and create greater efficiencies on some of those cost savings that I talked about. So I think it's very important that you don't ignore the knowledge and experience that comes from operations, production, maintenance, and that they become a critical part in that loop to optimize it and further enhance it, you know.
Yes, and that leads quite neatly onto one of the questions I was going to ask, which was we're getting more and more automated, lights out factories. Are we losing that engineer's intelligence as a result of that? Is that negative?
Yeah, it's very much a talked about situation across industry. As I said, I worked for a global automation company for 14 years. We were part of many global industry working groups. There was ARC, other industry forums, lots of companies doing different research in this area. There is a real concern across many manufacturers that the knowledge and experience of the older staff is being lost, and that the younger staff are becoming too dependent on the technology. So it is a very much a real concern, Andy, and that industry has acknowledged, and various industry groups. I even think like the Life Sciences Industry Group, the International Society for Pharmaceutical Engineering, the Industrial Society of Automation, all of these different industry groups are looking into these areas and seeing how can you transfer knowledge and experience, and that you don't just depend on the technology, and that you still need that human in the loop, to make some of the decisions.
Just add to it. Personally, I studied technology, and I know there was, even when I studied, and 2-3 decades ago, it was less and less people interested to work with the technology and engineering. And more people was moving towards the human science. And I think this was kind of peaking in recent times, and that's why we are very worried when we don't have in industry enough engineering knowledge. But recently, I've read an article which was saying actually opposite trend is happening, at least in the UK, and when actually people starting to assign much more into engineering than they used in last 2 decades. And there was actually, the article was outcry for human science. I was saying, but this is something which must happen, because we produce, and to be honest, we as an adult, we produce a new generation of technology users, which much less understand the technology in the deep dive. But that doesn't mean they're not going to be interested, and they're not going to be interested to work in a factories and in jobs. In some way, these jobs will become more interesting for them and tangible if they will have a right education to it, if the education will be tangible and feasible, and they would love to do it. And just a perspective of current, I do have a teenage boys, and I can tell you, they rather very easily slip to use some things much faster than my generation or my parents' generation. But if something is not working, they're not gonna deep dive why it's not working unless it's in their direct focus. If my oldest boy is direct focus physics, he will go to the bottom of it, and he will have a massive expertise in it. And this is the point what we need to do with the new generation, I think. to make it for them interesting, and make it for them interesting and reasonable to go that way, I think we will be surprised, but in probably decade or two, we can have so many engineers out there, so many scientists, when the technology hype will go absolutely skyrocketing. And, while we are afraid at this moment, yes, we are, because we are somewhere where the old style of engineering coming to end, but the new way of engineering is not still up there and running. And it's because of shortage of people, shortage of interest in young people. This will all change because there is a life going and we will need to evolve. If there will be no job to somebody do dancing for us all day, and I love dancing, I love it to have as entertainment, but there will be necessary to produce food, produce medicines, or making sure when you do have electricity at home, engineers will be always needed. And there will be absolutely.
Yeah.
I guess when there's a shortage, then hopefully the salaries will become more attractive, and ultimately we will.
Yeah, the other thing I would say, what is been explored what is being explored more by industry to use the technology, I suppose, in terms of to get younger people familiar. So like if we talk, like we're talking about software and IT and OT systems, right? That technology, I'm not so much worried about. That's where the young people are adopting very, very easy. But if you walk into a food and beverage plant, if you walk into a pharmaceutical plant or an oil and gas facility or chemical facility, it's less about the IT. It's more about valves, temperature sensors, motors, drives, process equipment, right? And the challenge that industry is facing is that's less attractive for the youth now, right?
Yeah.
That's becoming less attractive now. What I do like in particularly what I've seen in the UK, having worked there over the years, is there's a greater emphasis now on apprenticeship programs and that, yeah, getting young people into apprenticeship programs, and I think that's a really good way of combining industry experience and getting them, I suppose, interested potentially in that area. But you can also use technology. So what a lot of the industry forums that I talked about and also manufacturers, global automation companies are doing is they're building systems like augmented reality systems. So you can get a steam turbine, the exact replica of what you have in your process plant. And through augmented reality, you can train your new staff how to maintain that asset virtually and that. And then you have virtual reality systems, and they can link into CMMS. So like where the future of CMMS and maintenance might go is where engineers, technicians, maintenance personnel will have virtual reality systems where they will walk up to an asset, they'll see the asset ID, its tag, they'll be able to pull up a manual, and they'll be able to interact with the maintenance system through that, maintenance system through that. So the combination of those types of technologies, maybe apprenticeships, and that can help address the gap. But it's a big challenge for all industries, to be quite honest. The younger personnel are very interested in our sort of stuff, IT and AI and all of that. But when it comes down to the nuts and bolts, the valves, the processes and things like that, that's where there is a skill gap, and there's a fear that there's potentially loss of knowledge and experience not being transferred.
Definitely, yeah.
That, you know.
I mean, it's difficult to see a solution to it, really. I mean, I know that STEM courses are being given more priority in schools, so that hopefully will illustrate engineering as a much more interesting technology than perhaps it's thought to be.
Yeah,
but also you mentioned one important thing, the salaries, and how I ended up, for example, working in a power engineering, talking 15 years ago. I went actually from nice heated laboratory room into configuring and commissioning generators in Scotland Highlands. Then you can imagine yeah, the change of environment was absolutely drastic. But not everyone is happy to sit in a laboratory and work. And to be honest, I had after a couple of years more than enough, and it was find out it's not for me. Even it's a comfortable work environment, working with latest technologies on a computer. Not everyone is satisfied with it. And I think this is something which will wake up in most of the people. The second thing is what Andy was mentioning, a salary. And I can assure you that salaries in these industries will go higher than if you compare to people with sitting at home or for people which working from home. I personally working from home for 10 years, but I can tell when if you are tangible, motivated, and that could be salary, that could be interference with other people, uh, working in harsh environment could be no problem, and usually would be no problem if you want to set up your family, your career, and your lifestyle on something. Unfortunately, it's not yet there, and if you want to work as electricians, you will get a lower salary than if you are a programmer. Reason is because there is still bigger hunt for the programmers and more requirements from IT companies for programmers than is from OT companies for the electricians. But that's only to the breaking point when there will be broken factory and there will be nobody to fix it. And we're getting closer to that point. And as much good software we can have, or as many AIs we will have, will always need the people with hand skills and understanding the situations out there in a factory. As Donald said, also feed these informations, because we will have a less of these people. We'll need to manage them better. And that's where the CMS coming with is actually managing not only maintenance part and doing predictive, but also managing resources, human resources, with a good established skill set tables. And if you do have this type of problem, for example, electrical one, you're not gonna send a guy which is mechanical. An opposite way, which is happened many times. Oh, machine is not working. Send somebody. Doesn't matter who is it. It's not gonna fix problem. It's gonna make only more problems because it's gonna be longer time to fix it. But if you send the correct person because you know what's happened, then you can manage even the more scarce resources of the young engineers, but you do have a better management system on them.
Yeah.
Yes. I mean, Donald made an interesting point about augmented reality, but you actually need the input into the augmented reality from somebody who understands the engineering. So I suppose it's not a total answer. You end up getting to the point where how do the snow gritters get to work?
Yeah, I suppose where it's happening at the moment is so like there's various different technologies that are coming out. So in the augmented reality space, you have a lot of the OEMs, the original equipment manufacturers. So whether it's turbines, whatever, major pieces of plant equipment, and they're building augmented reality based systems to train based on their technology very specifically, not necessarily in use in process where it's in stream within the complete plant. But then your complete plant technologies then, so obviously I worked in the oil and gas industry for quite a long time. The oil and gas industry was very advanced, particularly in downstream refining operations. High fidelity simulation, also certain power plants were into that high fidelity simulation and digital twins, a complete digital representation of your plant. Now, digital twins is essentially what you're talking about there, Andy, trying to get a more specific representation of the facility that you're managing and maintaining and understanding that to a deeper level. And there's certainly lots of organizations that are building these digital twins. Again, automation companies, some of the big global automation companies are developing digital twins for facilities, etc. And that, yeah. So it's certainly the technology is evolving. Is it mass adopted in those types of systems? Digital twins, augmented reality, I would say no. There's been a lot of talk for the last 10 plus years, but there's certainly, I would say, the asset intensive industries realize there is a major problems with the skills gap, and they're having to drive that. I having worked with a Japanese company for 14 years there, automation, it was amazing to see how much, particularly in Japan, because there's a big labor force skill issue in terms of age gap and things like that, how they're utilizing these technologies to address those problems. And that, yeah, so it's not there, but it's certainly, it's acknowledged, the problem's understood, and the technology is being adopted, but not necessarily on mass scale yet, you know, those types of technologies. But I do think, like, going back really to the key point of the topic here, right? Those are very advanced technologies, and I want to emphasize the point around, just really for any organization, it doesn't matter what your whether you're utility, whether you're a food manufacturer is. I think the key to everything is, before you make your technology assessment as to what you're going to adopt, validate your assumptions. Yeah, like, you do know your business, but measure it, assess, and assess all aspects, because the reality is your assumption of we need this, until you measure and understand all aspects of, well, like we do maintenance maturity assessments ourselves, but until you measure all aspects, you might realize, well, actually, we're going to get a better return if we invest here rather than where we said we were going to invest, because the gaps are far greater here. But the ease of adopting the technology, implementing the technology, and the percentages of improvements are far greater. So measure and then decide, you know, what's your strategy going to look like in terms of technology and change, you know?
Let me just ask a couple more questions, and then we'll wrap up. I mean, I can't let you go without asking you some perception of how smart maintenance is varying across different countries, because you both have great experience of working in different environments. Peter mentioned in one of our pre-meetings the importance of the US market to Red Lion, so a lot of experience there. Also, a lot of experience in Europe. Donal, you'll know a lot about European, Irish, and the Middle East. Where do you see the key differences in the approach in those sort of different nationalities?
Yeah, there's various levels of maturity across different regions. Like, whether it's been in PEMAC or in my historical business, I worked all across Asia. As I say, I'm working in the Middle East now, Europe, US, and that. US tends to be very pro adoption and very adaptive towards new technologies and advancing in terms of market, and very much about driving pilots and proof of concepts, and help realizing and improving those very quick to market. And that the highest growth region, I would say, for maintenance and maintenance-based technologies is the Asian region, over the next number of years, based on industry reports, and that. So probably historically, it depends on the countries, I suppose. Like, as I said, Japan's very advanced in a lot of areas, but there's other countries that are still have low levels of technology adoption in that. But it is seen that over the next number of years, there's going to be higher levels of adoption there, and that. Across Europe, and it can vary based on industry, operational expenditures, what level of investment as well. Like, life sciences is always driving for improvements in terms of business process, research and development, technology adoption from industry working groups, regulations, and the manufacturers. It's very competitive when it comes to refining processes and adoption of technologies. So very advanced. So I think Europe is quite advanced and willing to adopt, but sometimes can be a little bit bureaucratic and slow depending on the industry. You know, that's what I find. Sometimes we get bogged down in regulation and red tape sometimes, and it can take a longer time to realize than say somewhere like the US and that, you know.
There is another difference, and that's more from kind of from the engineering point. You said right, Donald, in US there is adaptation of new technologies much faster, and in some way it's good to drive, for example, cloud services and similar stuff. But there is some things which is probably more on a cultural side. What I notice in European market, the people are much more like to hold their IPs, their knowledge by themselves, but also from engineering point. While in US, the engineers would like to have a easy, small, smooth, configurable system up and running ASAP. European engineer, from my perspective and my understanding, working with them for a couple of decades, is I want to have ownership. I want to understand the whole point and design the whole point by ourselves. And then you do have the massive, that's actually a massive difference in the cultural point. That's why the adaptation of the clouds probably in US is much easier, because they not really worried that much about, they'd rather adapt people, I would say, to the service or to the solution, to the system. While in Europe, I see more people rather, because they are having this more kind of deeper drilling into systems and deeper trying to design their systems by their own way, which is then harder to adapt what is on the market, because everyone's trying to adapt their own way. It's making more difficult to adapt to some things which is less flexible and what cloud technologies are, because they want to have their own unique approach. And simple things or one of a good example is I have one customer which producing just plastic sheets, nothing else. And he said, I want to have a complete knowledge of every process within the machinery happen. They stripped actually all the controllers which were supplied by OEMs and put their information, the old control system, their own processes, their own PID loops, because they developed some things which that was their own. They didn't want to rely on somebody else's help, and they want to be fully themselves. I don't know how much it's separated or change with the Asian market, but that's what I see in the European market. Maybe the bureaucracy is there bigger than, for example, in US, but I would sometimes question, because in US is much more to suit to put you in a court if you do some things differently. Then there is the other things is sometimes people doesn't want to deploy or some things to do because it's gonna get you into different type of trouble. I think European market is probably more bureaucratic, but also because it's trying to protect a bit more people than the technology itself. That's why I'm saying sometimes do projects for the sake of technology is not the right approach. The technology there should be for the sake of people, opposite way, and that's probably the main differentiator.
Between us, we could probably write a PhD on cultural differences across the world. I remember doing a case study, funny enough, for HMS with a distributor of diesel engines in diesel generators across parts of the Middle East, and he was saying that, it's very difficult to get remote monitoring up and running, because the culture is people are happy to go out and fix things, and it's cheap for them to do it. So that hadn't kind of
and if you're talking there is sparse Middle
remote
East
monitoring and to the degree that perhaps he and many of us might have expected. Yeah. So just to finish then, let's look ahead 5 years. What do you think is going to be different in 5 years' time compared to where we are now in terms of adoption of smart maintenance and the technologies that might be involved? Who would like to go first? There's a curveball for
I
you.
can go, but I can go, but you said 5 years, and this is a difference between IT and OT. IT is planning usually the assets for 3 years. OT is planning it at least for 10 years. Then if somebody develop or put the technology in a factory now, they're not gonna change it in 2, 3, 4, 5 years. They putting it there for at least for the decade. Then I would say there will be a couple of years where maybe decades too, when the new technologies will get more and more involved. At this moment, the OT layer is very sparse. Everyone's got something else. This gonna change, and I think over the coming years, the unification in OT space will become look maybe a bit more as a IT. More unified technologies with more unified communications will give you more unified data, and it will be easier to acquire for any IT applications out there, the connection, and then by utilizing the advanced IT technology to actually work with OT. But there needs to be the breakthrough when the IT and OT starts to work together, and maybe that's something which could be achievable within the half decade, the 5 years you mentioned. Then there is a big hope for myself, and with people like me and Donal working together with from two different aspects, this will become more common in industry, and people will look and not to be afraid to operate with other part of the businesses. Because at this moment, I still meeting with OT people which not talking to IT, and there is some kind of like distancing each other from each other. And I hope this is something which could change within the 5 years and could give the different kind of view. New people coming, new technologies will be more and more combining the OT and IT space. Then I hope that people will start to talk together.
Excellent. Well, there are two very positive ideas there, and you can have 10 years, Donal, if that makes it easy.
Yeah, look, I suppose the patterns we're seeing and the discussions that we're having with a lot of our clients, and what we're seeing through, whether it's be through user requirement specifications or engagements with our clients, whether through customer success, and that is predictive is front and foremost in terms of corporate strategies, understanding where it fits and looking at particular use cases and adoption of it, So I think it's going to be a slow journey, but it will be adopted. It's certainly in every plan that we see from the majority of our clients, particularly larger multinational clients and that. So predictive, so for predicting failures, suggesting corrective actions, etc., analyzing the data from the system, understanding what improvements can be made in that. So how can AI or predictive machine learning, whatever it is, be applied to your technology and system to help improve it over time? So I think that's a definite. What scale of adoption? I don't know yet. I can remember hearing about augmented reality and virtual reality 12 plus years ago, and I still haven't seen them to mass scale adoption in that. But I think condition-based monitoring linked in with these types of systems to create integrated workflows, so building ecosystems to optimize integration and workflows across operational systems is another thing. You'd be surprised, although there's lots of different systems, there can be low levels of integration, and even integrations and creating those workflows and automations across those systems can create a huge amount of efficiencies and gains in that. So creating holistic ecosystem for maintenance is also something that I see happening as well. Yeah.
Excellent. Okay, well that's fantastic. It gives me a lot of useful information. I'm sure those on the call and who will receive this later will find that all very valuable. We'll distill that down into articles, podcasts, and perhaps a LinkedIn conversation, taking some of these ideas further over the next few weeks. So thank you to everyone who's attended. Hope you found it useful, and thank you very much to our two speakers who've contributed a lot of good ideas and a lot of thoughts over the last 80 minutes or so. So with that, I guess it's just about time to wish you all a happy Christmas, and we'll be back in the new year with another set of Talking Industry panel discussions. Thank you very much indeed.
Thank you very much, everyone.
Cheers.
Thank you.
All the best.